Hey, good morning and good afternoon, everybody. Today is Wednesday the 6th. Um, just two assignments this week. We got the Monday assignment, which turned in yesterday or Monday. And then today's Wednesday, and we're going to do the rest of section 11.8, the video notes here, and then the assignment is going to be due by Thursday. Now, nothing on Friday, and then we'll pick up next week, and then we'll actually have another quiz next week. And as we go through here. All right, let's kind of go through what we're doing. We had, and let me get rid of myself here. Multiply and divide radical expressions. And we did the multiplying Monday. Now I just want to run through real quick. Let's do this here. Here's your answer sheet, which should be posted on the Canvas one. And the key thing here is you got to multiply outsides by outsides and insides by insides. Just take a look at here. So you have access to what the answer should look like with all your work. And then one thing you really have to watch is like with 16 and 18, when you have that quantity squared, make sure you write that down twice. It's just a lot of times people just want to square this and make it 25 plus 3. You have to write it down twice for that. Now, this is not part of the guided notes, but just let me run through this real quick. Just pay attention, kind of review here. Now, remember, this is not a FOIL problem because you don't have a plus or a minus in between here. This is just multiplying two terms, and you just take the outsides together. I shouldn't even do that because you'll think FOIL. You'll take 3 times 5 is 15, and then you take 6 times 2, which is 12. Now, you always have to reduce. 12 is 4 times 3. 2 times 2 times 3. And then so we get 15. 2 times 2 times 3. And then the 2's come outside and multiply by that 15. And that would be our final answer. Now for number 2, these are basically the 3 types of problems. You get a term times a term. You distribute. 2 times 5 is 10. Square root of 3 times square root of 3 is 9. And then we distribute 2 times 4 is 8. And then 3 times 2 is 6. Well, square root of 6 doesn't reduce, but square root of 3 does reduce. What's the square root of 9? Square root of 9 is just 3. Okay, not square root of 3, but 3. And you multiply those two together and you get 30. So that would be our answer for number 2. And then number 3, this is a FOIL problem. You got a binomial times a binomial. 4 times 6 is 24. 4 times negative 3 is the only thing you can do is write as minus 4 square root of 3. And then square root of 3 times 6 is plus 6 square root of 3. Positive times a negative is a negative. 3 times 3 is 9. 24. These two are like terms. They combine to give you plus 2 square root of 3. And now square root of 9 is 3. 24 minus 3 is 21. There's our answer. 21 plus 2 square root of 3. So that's a quick review of the multiplying. Really, there's 3 types we run into. Just a term times a term. Distribution where you have a single term times either 2 multiple terms, and then a binomial times a binomial. Okay, a FOIL problem. But now we're going to divide. Now, and actually with divide, we don't technically go through the whole division. I'll have to explain that here. A quotient, now we're on your guided notes. A quotient with a square root in the denominator is not simplified. And we've said we don't want to leave that. You cannot have that as an answer. We haven't dealt with it yet. So like 2 over square root of 3. Cannot leave that as an answer. 5 square root of 2 over square root of 8. You cannot leave that as an answer. To simplify these expressions, multiply by a form of 1. Well, a form by 1 would be like 2 over 2. 3 over 3, but what we're going to use is we're going to use like square root of 2 over square root of 2, square root of 3 over square root of 3. Okay, that still equals 1. So what it does is it doesn't change our value, but it's going to do what we needed to do. So we're going to do this to get a perfect square radicand in the denominator. This is what we call rationalizing the denominator. Okay, sometimes I'll just kind of refer, because I'm just used to this, I'll just say, okay, rationalize the denominator. Well, this is the process that we're going to use. When we're done here, this is kind of the process you want to use. You want to reduce fractions. You want to simplify radicals. Remember, simplify radicals. That means square root of 20. After you do the factor tree, that's 2 radical 5. Like square root of 24, that's 2 square root of 6. Okay, that's how we simplify. We'll rationalize, and then we'll simplify again if needed. Rationalize is the kind of the part we're going to add in today. All right, here's the first case. I cannot have a square root of 2 in the denominator. Not allowed to. Nothing divides. You cannot take a number inside a radicand by number outside and do. You can't multiply, you can't divide, you can't do anything. This is where we multiply by a factor of 1. And here's all we're doing. Whatever's underneath the radical, multiply top and bottom by that value. Multiply top and bottom by square root of 2. Now, 5 times square root of 2. You cannot multiply those together because 5 is not under the radicand. This is the only thing you can do is write as 5 square root of 2. Here's why this works. It's because square root of 2 times square root of 2 is square root of 4, and square root of 4 is 2. Okay, now you can probably skip the square root of 4 part, just write 2. Hopefully you recognize that. Square root of 2 times square root of 2 will end up being 2. And now we are done. We look to simplify the 5 and the 2, but nothing can simplify, so we leave that. So here's what's going to happen from here on out, and this is why this works. Anytime you take a square root and you multiply it by the exact same thing, 3 times 3 is 9. You end up with 3. You end up with whatever that number was. So if I take square root of 5 times square root of 5, that's square root of 25, which is just 5. Square root of 6 times square root of 6 is going to be, technically it's square root of 36, but it's just going to become 6. So if I took the square root of 182 times the square root of 182, when I'm done, it's going to equal 182. It's going to be your rule from here on out. And that allows us to rationalize the denominator, okay, for these problems, or to get rid of that square root. So we want to get rid of the square root in the denominator. So square root of 3, multiply top and bottom. This is by that factor of 1, by square root of 3. Well, this is inside the radical. This is inside. That gives you square root of 33. Over 3 times 3 is 9, but we know the square root of 9 is 3. You can jump straight to that 3 if you want to. All right, what you need to do is anytime you get a radical, you try to reduce it, but that's only 3 and 11. That does not reduce any further. This is all we get right here. That is our answer. Okay, square root of 33 over 3. This is called rationalizing the denominator. Square root of 13 over square root of 5. Okay, same thing here. Multiply by square root of 5 over square root of 5. Square root of 5 times square root of 5 is 25. Square root of 25 is 5. 13 times 5 is 60. Now, this one reduces. It's the first one we've come to that reduces, because 60 is 10 times 6 is 2 times 5 is 2 times 3. Actually, 13 times 5 is not 60. I lied to you. It is 65. All right, it is 65. And now 65, that does not reduce because that is 13 times 5. And that's all you can do with that one. So we are done actually with this one. That's all we can do. Square root of 65 over 5. So if you just got a radical, just all of these three have been very similar. Just say like a radical 2, a radical 3, a radical 5. Multiply the top and bottom by that. Square root of 13m times square root of 20. Okay. Now you can do this two ways, and I'm going to show you both ways. So what I can do is I can multiply by top and bottom by square root of 20. It's 20. 13 times 20 is 260. So that becomes square root of 260m over 20 times 20 is 400. But you should know from what I taught you earlier that this is automatically going to be the square root of 400 is automatically going to be what? It's going to be 20. Anytime you take a square root times itself, you're going to be left with that number. All right, we need to factor tree 260. It's 10 and 26, 2 and 5, 2 and 13. So I get 2 times 2 times 5 times 13. Don't forget the m. Pair of 2's. So 2 comes on the outside. 5 times 13 is 65m over 20. Now, you always want to check and see if these numbers on the outside, they are not in the radical, if they reduce. And 2 over 20 reduces. And that becomes 1 over 10. Now, technically, I don't need to write the 1, but it doesn't hurt anything. So there's our final answer. Square root of 5, square root of 65m over 10. All right, now, like I said, let me see something here. I'm just going to leave that. I might come back to it in a minute. Let me come back to it in a minute because I want to keep working first. Show you something here in a second. All right, 2 square root of 80 divided by square root of 7. Okay, multiply top and bottom by square root of 7. Now the 2 is on the outside. That's like having a 1 on the outside, so it's going to be 2 and then square root of 80 times 7. Whoops. You get 560. Now, square root of 7 times square root of 7 is 49. Square root of 49 is 7. Now, 560. Let's see what happens here. If it ends in a 0, that means 10 goes into it. 10 times 56. And 10 is 2 times 5. And 56, 7 times 8. And 8 is 2 times 4, and 4 is 2 times 2. So what do I end up with here? You got the 2 that's already on the outside. You got 1, 2, 3, 4 2's. I got a 5 and a 7. And then I got a 7 on the bottom. Remember, pairs come out. I got a 2 already out there. I take out 2 more 2's, multiply the 5 and 7 together to get 35 over 7. Multiply those 2 back together. 2 times 2 is 4. 4 times 2 is 8. 8 square root of 35 over 7. Okay, that's our answer here. Final answer. Cannot have a square root in the denominator. We do not. Okay, now this one here. This one is slightly different because all the other ones just had like a 7. All right, or a 5, square root of that. This one has 5 square root of 2. The easiest way to do this one is all you have to do is figure out what is underneath the radical, and you multiply the top and bottom by that. Now, when we do this, 5 square root of 2 times square root of 2 becomes 5 square root of 4. The top becomes 3 square root of 20. Well, square root of 2 times square root of 2 is 2. Square root of 4 is 2, so this becomes 5 times 2. I'm just taking an extra step here, which is 10. So the denominator ends up being 10. All right, well, square root of 20. Let me do something here. I'm going to go back. 20, I need to do factor tree on that one. That's 4 times 5. That's 2 times 2. So I have a pair of 2's, multiply 2 times 3, 6 square root of 5. All right, now we've done everything correct and to this point, but we are not done because the last thing you have to do is try to simplify fractions, which means this 6 and this 10 can simplify because they're both divisible by 2. So in the end, I get 3 square root of 5 over, this becomes a 5. So 6 over 10. They're both divisible by 2. That's 3 over 5. Okay, now let me go back to D. And here's what I wanted to do with D. I wanted to do that one first. So there's 2 ways to do it. So you got square root of 13m over square root of 20. If you have a number in the denominator that reduces 20, reduces to 2 square root of 5, you can do that first and maybe save yourself a little bit of reducing at the end. So, but now I wanted to do the one before so that we talked about if you have a number on the outside and the square root, you just multiply by the square root. Whoops. So this becomes 2 square root of 5 times 5. Well, that's 2 square root of 25. This becomes square root of 65m. And now square root of 25 is 5. So that becomes 2 times 5, which is 10, square root of 65m. So we get the same answer we did here. This might be slightly easier because if you reduce first, okay, you save some reducing later. Okay, do you have to? No, you can multiply by square root of 20 over square root of 20. You can do that, but like I said, this is makes it a little bit easier for that one. All right, not a lot of problems or not a lot of examples for this section, but make sure you use your notes and kind of go through here. Here's your homework assignment. We'll be doing a Canvas conference later today and tomorrow, and this might be a good one to come in and maybe get some homework help on. All right, because we're going to do this section here, and then we got another section next week, and then we're going to go ahead and take another quiz. And then we're getting towards the end here, so take a look at where your grades are. You want to make sure you keep them up. All righty, you guys have a great day.